On the morning of February 28, 2017, one engineer at Amazon typed a command with one wrong number in it. Within minutes, a huge slice of the internet simply stopped working. Slack, Trello, Quora, Medium, parts of thousands of other sites, all dark. And here is the detail I love most. Amazon could not even tell the world what was happening, because the dashboard that reports outages was itself hosted on the service that had just gone down. We like to say, a typo broke the internet. I want to convince you that the typo was never the real problem. To understand how one command did this, you have to understand what S3 actually is. S3, the simple storage service, is where an enormous amount of the internet keeps its files. Images, videos, backups, app assets, entire static websites. By 2017, so many companies stored their data in S3 that it had quietly become load-bearing infrastructure for the web itself. If S3 in its main region went down, it did not just take down Amazon, it took down everyone standing on top of it. That morning, the S3 team was chasing a billing system that was running slow. An engineer was following an established playbook, a routine procedure to take a small number of servers offline and investigate. This was normal, it had been done many times before. But one of the inputs to the command was entered incorrectly, and instead of removing a small handful of servers, the command removed a large chunk of them, and not just any servers. The ones that got swept away supported two systems that S3 absolutely depends on. The first is the index subsystem, which is basically the card catalog of S3. It knows where every single object lives. Without it, S3 cannot answer the most basic question there is: where is your file? The second is the placement subsystem, which decides where new data gets written, and it leans on the index to do its job. Knock out enough of both at the same time, and you cannot read, you cannot write, you cannot even list what exists. S3 in that region went silent. What made it worse is that S3 was not just load-bearing for other companies, it was load-bearing for Amazon itself. Other AWS services in that region quietly used S3 under the hood, so they started to stumble too, launching new servers, certain dashboards, pieces of the machinery the rest of the cloud depended on without anyone really thinking about it. The failure rippled outward from storage into services that on paper had nothing to do with storage. That is what hidden dependencies do. They turn one failure into many. Here is where it gets interesting and where I think the real lesson lives. Amazon found the cause quickly. The fix was conceptually simple: restart the subsystems. But these systems had not been fully restarted in years, not in the big regions, because S3 had grown so enormous. Restarting them meant running safety checks across a mountain of data that had quietly multiplied over time. The system had outgrown its own recovery plan. So the 4-hour outage was not 4 hours of confusion about what broke. It was hours of carefully bringing a giant back to its feet, one safety check at a time. And during all of this, remember that dashboard, the AWS Service Health Dashboard, the official place you go to check whether AWS is up, could not be updated because the console that runs it depended on S3 in the very region that was down. For the first 2 hours, Amazon had to report the biggest cloud outage in years using a status banner and their Twitter account. The watchman was locked inside the building that was on fire. Now the easy story here is that an engineer fat-fingered a command and broke the internet. That story is satisfying and it is completely useless. Because think about what it implies, that the fix is to be more careful, to somehow hire only people who never make typos. There are no such people. Every human who has ever typed a command will eventually type the wrong one. If your system can be brought down by a single mistaken keystroke, the keystroke is not your problem. Your blast radius is. And to Amazon's credit, that is exactly the lesson they took. Their postmortem did not name and shame an engineer. They changed the tooling so it removes capacity slowly and physically refuses to drop a subsystem below a safe minimum. They audited their other tools for the same missing guardrail, and they began breaking the index subsystem into smaller, isolated cells, so that the next mistake could only ever damage a small piece instead of the whole thing. They treated human error as a given and engineered the consequences away. This is what people actually mean by a blameless postmortem. It is not about being nice, it is about being effective. Blame ends the investigation at the person, which is a dead end, because you cannot patch a human. Curiosity continues it to the system, which is the only place you can actually fix anything. The outage cost companies an estimated hundreds of millions of dollars combined, and it taught the whole industry a lesson it had been avoiding. If your entire product lives in one provider, in one region, you do not have a backup plan. You have a single point of failure with good marketing. The 2017 S3 outage is remembered as the day a typo broke the internet. But the people who learned the right lesson remember it as the day they discovered their blast radius was the whole world and decided to shrink it. The typo just told them where to look. And if you got something out of this, do the one thing that actually moves the needle for a channel like this. Like it and subscribe. The algorithm is listening. See you in the next one.